Hello everyone, welcome to this next video on complex analysis. Here, this question is from December 2014 and it is of 3 marks. And the question says, if k be the given positive integer, then the radius of convergence of the power series, this is the given power series, and they are asking the radius of convergence is equivalent to which of the following 4 options. So out of these 4, what is the radius of convergence for this given series? So here, let us denote the radius of convergence by the letter capital R, and in this power series, we can write it in this form: n varies from 0 to infinity, a n z minus 0 raised to power n. So the power series is about the point 0, and this is the coefficient term. So what is an? An in this case is n factorial raised to power k divided by kn whole factorial. So this is the given information to us. So in order to calculate this radius of convergence, we could have a look at this result by Cauchy's, namely the Cauchy's theorem. So they are saying, if we have the power series something of this form, then the radius of convergence is given by either of these two formulas. So first is using the root test, we can calculate this radius of convergence, and second is using this ratio test, the radius of convergence R is given using this formula. So here in this, in order to solve this question, we can use any one of these formulas, but as for now, I'm using the second formula given over here. So what is our an? An is this one, right? So what would be our an plus 1? It would simply be n plus 1 whole factorial raised to power k divided by k as such. K is positive integer, so it would be as such, n plus 1 whole factorial. So this is given to us. So now let us calculate the radius of convergence using this second formula. So in order to calculate this radius of convergence, let us solve this thing. So we would be solving limit n goes to infinity mod of an plus 1 divided by an. So we would have something like this: limit n goes to infinity. What is an plus 1? It is n plus 1 factorial raised to power k divided by k into n plus 1 whole factorial, right? And multiplied by this thing will invert itself. So you will be having kn factorial divided by n factorial raised to power k. So now we have to simplify this term and calculate the limit. So let us do that. Limit n goes to infinity as such. So now we can write n plus 1 factorial as n plus 1 into n factorial, no problem in doing that. So we have n plus 1 into n factorial whole power k, right? Similarly, here we have kn plus k. So kn plus k factorial, this term is equivalent to this term, and you can write this term to be kn plus k into kn plus k minus 1 and up to kn plus 1 into kn factorial, right? No problem in doing this also. So let us use these two results over here to simplify the relation. So we'll be having kn plus k up to kn plus 1 into kn factorial. This is the first term, and the second term over here would come as such. So now can you see this term over here cancels with this term, and this term cancels with this term. So we are only left with limit n goes to infinity n plus 1 raised to power k divided by kn plus k up to kn plus 1. So this is what we are left with. Now in order to calculate this limit, that is substitute n going to infinity, we'll convert this form to 1 by n's. That means what we do, we take n common from here. So we'll be having n raised to power k common. So we are left only with 1 plus 1 by n raised to power k, and similarly if you take n common from each of these terms, we'll be having n raised to power k. Why? Because the power is k here because these are total k terms. So from each of these k terms you will take n common, so we'll be having n into n into n. How many times? K times, so n power k, and we'll be left with k plus k by n up to k plus 1 by n. So now we can substitute this limit n going to infinity in these. So we'll only be left with, so obviously this terms cancels with this one. So now you can substitute the limit n going to infinity. So when you substitute the limit over here, this term would become 0, this term would become 0, and this term would become 0. So we'll be left with 1 raised to power k divided by k into k into k. How many times? K times, because they were total k terms. So these were total k terms. So we are left with 1 upon k raised to power k. So our radius of convergence, the formula was 1 upon r is equal to this thing. So obviously the radius of convergence comes out to be k raised to power k for the current case. So let us have a look at our options. So accordingly, option 3 comes out to be the correct option. Well, that is it for this video. Thank you for watching.